Dear Minister, dear colleagues, it's a great pleasure to be here. I'm a Danish professor in economics. I came from Sweden, and as I told the minister, I never finalized my PhD. I think I might be the only one person in this room without the PhD. I'm afraid so. I was in the midst of writing my thesis on the falling rate of profit of Karl Marx. And I also produced a textbook on Marx economics in 1969, the only one ever published in Sweden. But I have a funny career, so after that I worked 3 years at OECD. You might know it's a very neoliberal economic think tank for the rich countries. And I was never convinced about this neoliberal message. I got even more critical by working in that period, but I learned a lot. I've been a visiting professor in China for 3 years, and that has been very useful to understand a lot of things going on in a very important country. In many ways, China, what's happening there will have a major impact on what's taking place elsewhere. What I'm going to do today is actually to, hopefully within 1 hour, so we have a lot of time for discussion afterwards, because I think discussion is very important. What I'm trying to do is to present the most important results from my research over a period of 40 years in 1 hour. So we'll see what's going to happen. My most important contributions has been to develop some conceptual frameworks, some concepts. One of those concepts has to do with innovation as an interactive process in general, but specifically the kind of interaction which is necessary between those who develop something new, who develop a new product, and those who are going to use it. The kind of feedback between the two. I worked on that in the middle of the 1980s. Later in the 80s, I introduced, together with Christopher Freeman, who is my great mentor from Science Policy Research Unit, you can say he's the very founder of innovation studies in the world. Together, he came to Aalborg. We became very close friends. He's also, by the way, an old Marxist. So we found each other, and together we developed the idea of national innovation systems. We are going to speak about that. And the third major concept I developed when we were writing the book in 92 on innovation system, we introduced the concept of learning economy. And the idea of the learning economy I will also try to introduce today to you. And then, since 2002, my main activity has been to build and coordinate globalisation, and I think Aurora said a few words about that. So, now the structure of my lecture, I will start talking about innovation as an interactive process. I will talk about the national system of innovation. I will talk about the learning economy, and then after that I will try to draw the implications. What lessons can we learn in relation to how to organize, what content should innovation policy have, and how to organize innovation policy. I'm going to raise the question how to organize universities in the context of a learning economy. I'm going to discuss how to organize enterprises in the context of a learning economy. And then at the end, I will talk about how globalization will impact upon these processes and how it affects the challenges for policy, universities, and enterprises. This is what I'm going to try to do. We'll see. Okay. it's obvious that science is extremely important for innovation. And the idea of science as a productive force, you find it very strongly with Karl Marx. And you also find it actually with Adam Smith. Adam Smith, he points in the very introduction to the famous book on Wealth of Nations, he points to what he called men of speculation. People like you. You are all men of speculation. People who use their brain, that they are very important in developing new ideas which are transformed into new products and new processes. Later on in the 1930s, there is a very famous natural scientist, John Bernal, who for the first time tries to measure the amount of research and development as compared to the national income in England. And what he comes out with, do you want to guess how much percentage R&D would be of national income in England 1935? What do you think?
No idea.
Somebody have an idea?
1%.
No, not so much. 0.3%. And Bernal said in the 30s that if you can increase this tenfold so it becomes 3%, England would become a very rich society. So he was one of the first who tried to put numbers on the importance of science. And then, no, not yet, because then there was this report by Vannevar Bush, who was a very important coordinator of the war effort on the science technology side in the United States. And he was also involved in the Alamo project and things like that, building the nuclear bomb. But he wrote a very important book called Science, the Endless Frontier. And what does it mean, the endless frontier? You have this pioneer idea in the United States, you go further and further west, you colonize the country. But science is different because you can go on. There's no Atlantic or any limit. There's no frontier for the pioneers in science. This message was so important for establishing a strong belief in the importance of science for economic and social development in the United States. A lot of the major programs, not only the military programs, but also in health science, etc., were established on the basis of this belief. So science is a productive force, but the way we go from good science, high quality science to innovation is not simple. It's not a linear way. It's not say, now we have good science, now we get innovation. No. It's much more complex. It goes back and forwards. If you do not have users of science, you will not be able to develop good science in the long term. Feedback from the users is important at every single level. Even if you talk about basic science, you sometimes assume there's no users. But of course there are. If you take mathematics, when you develop computers, etc., you get feedback and you stimulate the basic science. So at every single level, there is an interaction going on. You can exemplify this in different ways. Innovative firms interact with customers, suppliers, and knowledge institutions. This is one very important result of innovation studies, that firms that are enterprises that are successful in innovation, they have much stronger interaction with customers, with suppliers, and with knowledge institutions. Also, we find inside the firm, if you have an organization, not only firms, but also other organizations, if you have very clear barriers, high barriers between different divisions or different disciplines within a university, you will get very little innovation. The way you get innovation is to lower the barriers, increasing the horizontal interaction between different divisions, different disciplines. Finally, I talked with the minister earlier today that if we take Silicon Valley, we often assume that the reason you got Silicon Valley in California was because they had strong universities. This is only half truth. The other part of the truth, the reason you will get very strong research in Silicon Valley was that they had very advanced users. Very often during the development of information technology, the enterprises were far ahead of the scientific laboratories. So at all levels, having feedback from users is crucial for the success of developing knowledge, developing innovation. So this idea of innovation as an interactive process. The next step was to think about systems of innovation. Because then we could think about, we are not only interested in the quality of universities. We are not only interested in the capabilities in enterprises. We want to see how these relate to each other. We want to understand how they form a system and the quality of the relationships between the different components of the innovation system. So this is a broad definition. The national innovation system is open. It's very important that there are no successful innovation systems which are completely closed. Not at the regional level, not at the national level. And today, in many cases, innovation systems become increasingly dependent on their openness and the way they handle their openness. I'm going to speak more about that. They are open, they are complex, they encompass institutions, and here with institutions, I don't mean university. I mean more the way people relate to each other. It's a more sociological concept to some degree, institutions here. And it's also about the economic structures, because what you do determines what you know. Because the basic idea of our approach to innovation is that learning by doing, learning by using, and learning by interacting is very important. And it means that what you do, where you have, in Cuba, you have a very strong health sector. And this is reflected that you have a very strong biotechnology industry, because you develop knowledge by doing, and then you can build scientific capability. The quality of its small elements and important, the quality of the university, the quality of the research taking place in enterprises are important. But the relationships are also important. And they determine the rate and direction of innovation and competence building. And also here we insist on the importance both of science-based learning, I'm going to come back to that, and experience-based learning. Both are important. So you can say that the roots of the innovation system was the new understanding of innovation as an interactive process, but it was also the new understanding of knowledge as a combination of tacit and explicit elements, and how this is reflected in how innovation processes are either local, regional, national, or global. So you can say, in a sense, that innovation is all about knowledge. I would say the characteristic innovation is a new combination of diverse elements of knowledge which are already there. It's a cumulative process in the sense that most innovation is just to combine existing knowledge in a new way. And what comes out of the innovation process is this new combination, which is new knowledge. So in a sense, it's like potatoes. You put potatoes and you grow potatoes. You start with knowledge and you end with knowledge. And therefore, if you want to understand innovation, you need to reflect deeply on what is knowledge. And this... So in economics, there are different points of view. Marshall, who is actually one of the fathers of neoclassical standard economics, British economist, he studied what he called the industrial districts in a kind of historical context in England. And what he found was very confusing, because he found that Sheffield, they had been experts in steel making for 150 years, and they were still leading. Why did this knowledge stay there? And he found other districts producing cotton or something, the same story. You had very localized, rooted knowledge. So that's one approach. And if you look at that, you say a major issue is how to diffuse knowledge. This becomes a very important thing for innovation policy. And it's also a question when enterprises localize themselves, like today we would speak about Silicon Valley typically as the example, where you have this concentration locally of knowledge. On the other hand, we have in economics the idea that knowledge is like information. It's scientific information. And then you have the problem actually that if it's a public good, anybody can access to it. How can you protect it? So you have two different sides of innovation policy: how to diffuse it and how to absorb it, and on the other hand, how to protect it. And immediately this seems to be opposite each other. How can knowledge be localized and at the same time be a public good? And the answer is, of course, is that knowledge are very different things. And they are composed of a mixture of explicit codified elements which we can call information, and which can be sent by this computer in a second to the other part of the world. And if you have somebody who receives it, who has a competence, this person or organization can use it without problems. But the other parts of knowledge which are tacit. And tacit means that you cannot really write it down. You cannot write it down in a program or in a computer. It's actually embodied in people. Much of it is embodied in people, and I say this knowledge is not embrained, it's not in the brain, it's in the body. And I think the most important part of the body here is your backbone. You have it here in your backbone. And when you talk about tacit knowledge, you normally talk about something like going on a bicycle. Probably most of you can do that, but you cannot learn to do it from a computer. Or you talk about swimming. But this is so misleading, because every single of you have a lot of tacit knowledge. I worked at the OECD, and I had a Japanese boss who was a little too, he liked too much US information management. So he said, now every person in our directorate should write down exactly what they are doing. So if they leave, I can give this paper to the next person who can do exactly the same thing. And of course, this doesn't work. Because you know a lot about things you are do in your profession as a manager, as your profession as a rector, or your profession as a minister. You know a lot of things which you know how to do, but you couldn't just describe exactly why you know how to do it. I hear this story about very advanced natural scientists. When they are in the experienced people, when they are in the laboratory, they might make an experiment and something shocking comes out. It's completely wrong. And if you are a young, unexperienced scientist, you may become very depressed. If you are a very experienced one, you might say, this is, because now I remember, this happened the other way. The memory you have got by learning by doing, learning by using, and learning by interaction is really what makes your capacity as a scientist, when you get more experience, to be somewhat better than the new ones. Even if we agree that young people can be smart and efficient. We talked with the minister about that earlier today. To solve this contradiction, we need to distinguish between knowledge about the world, which we can codify. A lot of the knowledge about the world we can describe, etc., but knowledge how to change the world, know-how, and even some kind of know-who, getting social intelligence to interact with that. It's not something which can move around easily. Okay. On the basis of this distinction between tacit and codified knowledge, we thought we would try to see, could we make a distinction between different types of learning, where one type of learning would be more oriented towards codified knowledge, towards science-based knowledge, and the other one towards experience-based knowledge. And we based this study on 700 enterprises in the private sector in Denmark. And what we distinguished between were firms which had scientists as employees. They were interacting with universities, and they had their own research activity. These firms that had that, we said, they use the STI mode, the science, technology, innovation mode learning. And then we looked at the others, which were firms that were engaged, so had learning organizations. Do you recognize the concept, learning organization? Some of you do. Learning organizations, they are flat. Not too much hierarchy. They have a lot of interaction inside the organization. They have good connection to customers. So we said in those firms who had these characteristics, we say they are engaged in learning by doing, using, and interacting, especially interacting with customers. And then we made some kind of cluster analysis, and the paper is presented there. We can take the next one. What we find, we have a benchmark category which is 1. And we find that the firms who have a strong experience-based style of learning but no science-based learning, or weak, they are double as innovative in terms of developing new products as those who are not practicing any of the two modes. The same for those who are strongly organized around science-based learning. They also double as. But if we look at the firms which combine the two, they are 5 times. They are 5 times as innovative. So what we found here, and I think it's very important for understanding innovation process, in enterprises, and also for developing the right kind of innovation policy, is that what is needed is a combination of science-based learning focused on more codified knowledge and more experience-based learning involving learning organizations interacting with customers. You need both. And it's a very important point. If you, for instance, have a situation where you start new enterprises by academic entrepreneurs, they might to become very STI-oriented, not really being strong in developing learning organization and interaction with customers. Many traditional family firms will be very far away from science, universities, and all like that. But they might understand the process of DUI. So I would say innovation policy, what you can do is to promote DUI for this kind, to promote organizational learning, strengthen the connection to the market, to users. And for this category of firms, we found that if you stimulate these traditional firms without science context by, for instance, getting them to hire some students or some new candidates, you increase their understanding of STI and you can increase their innovation activity quite strongly. So you need to think about innovation policy in both these terms. I think that's important, and the same is for innovation, innovative enterprise management. So when you think about innovation and innovation system, it's often you have this idea that it's something where you have professors, you have scientists. I met some of the most fantastic scientists at the biotechnology center the other day. You have those, and you have managers in big enterprises. You might have engineers, and you have university rectors and university scholars and so on. Innovation is something even broader than that. What we found is actually that how you organize work is fundamental for innovation. And it's very different. Actually, when we compare different countries in Europe, the difference in terms of how you organize work and what you learn at the workplace is more different than how you organize science or universities. Looks very similar. But when you go, and this is why national systems are more national than some people believe, because in science we of course have international, global interaction, but there's also a lot of learning processes which involve ordinary people, both workers and farmers. And what we did here, we used some very interesting survey data covering 29 European countries. Here I only give you 9. And we tried we made clusters which were reflecting different combinations where creative workers here. It refers to workers who have some independence, some autonomy, and at the same time say, we learn a lot at the workplace. Routine problem solvers are more in between. They learn some stuff, but they have very little freedom. Very little freedom. What they learn is strictly determined by some routine processes. And finally, I guess you heard about Taylor and Taylorism. Taylorism, you learn almost nothing. You do this all the time, or that all the time. You do that. And we found, when we compared the composition of the workforce in Europe, the northern part the southern part and the eastern part, we found so dramatic differences. Actually, a big majority of workers, and this includes all types of employees, even what you call normally unskilled workers. We find that people which you wrongly refer to as unskilled workers in these countries, they are engaged in problem solving on their own. But this happens much less in the south of Europe, and it happens also much less in the east of Europe. On the other hand, we find there are almost no tailorized jobs left in these countries in the north, but there are much more tailorized jobs here. And of course, this is one reason why the European Union is in trouble, because they have integrated these different economies without making a major effort to change how people work. They just integrated European monetary union, and of course Greece got into trouble because Greece and Italy, etc., they were competing with China. Work on taylorism. Quite different. So you created something which was not coherent. But that's another story. My point here is to say, next one. We find a very strong correlation between the proportion of creative work in the economy and different indicators for innovation. Here we take patents, but we could take, we have done this for other indicators. So it means that innovation is not only for us here in this room, not only for managers, not only for research professors and ministers, it's also for ordinary people. How we organize activities in the daily life, I think even in the family, how we organize that will influence how we shape people. And how we shape people will determine how they interact or do not interact. So we need a very broad understanding of innovation system. So now I move to my third concept, which is I refer to as the learning economy. And this idea is very simple, and it has been taken over many places. The most recent one, I can tell you, is interesting, is that Professor Stiglitz, you know Stiglitz? Yes. He's now writing books and articles on the learning economy. I do think he forgets to refer to Lundvall, but because we developed these ideas around 1990. But he has found that this is a very useful concept, so he's writing papers and books about this. But the basic idea is so simple, is to say we are in a world with very rapid technological change. We are in a world with globalization, with radical change in competition and markets. We are in a world where deregulation of financial markets speed up things, and we are not least in a world where information technology speeds up change. And it means that a lot of people realize that we are in a knowledge-based economy. My point is to say this is not completely the full truth, because we are in a knowledge-based society, but we are also in a society where the capacity to learn, also to sometimes forget the old way of doing things, is really what is the most important characteristic. And this has, we can see it, we have shorter product life cycles, shorter lifetime for competencies. A very interesting example was that at some point when you had the most dynamic development of engineering in computers, it only took 1 year after you left your university until half of what you had learned had become obsolete, not useful anymore. And other studies show that this halving time might be like 8 years, but still it's very short. So when we train people at our universities, we should know that some of the stuff they learn, they should forget. And they will always have to learn new things. So let's move. There is one basic contradiction in this learning economy, and that is that learning is a social process. It's a social interaction process. And it means that if you have too big distance, too big gap between people, if you have people very high up and people very low down, very hierarchical system, or you have very, very poor people and very, very rich people, it undermines the learning economy. But at the same time, if you leave it to itself, it tends to become more polarized. Because normally those who have some knowledge are privileged in terms of learning new things. So you have, I don't know if you read the Bible, but there's something called the Matthews syndrome. You know Matthews? For those who already have should be given more. And those who have not, we should take that away from them. So we have the learning economy is a Matthews-like thing. And this is why we need strong investment and in the weakest among the weakest learners. I call this a New Deal. You know the New Deal in Roosevelt was to give money to poor people. The New Deal is to invest in knowledge for those who have least knowledge in order to keep them into the learning economy. If we don't do that, we will weaken the capacity to learn for society as a whole. So, innovation policy, it's obviously about building science technology platforms and promoting collaboration between enterprises and universities. This is what I refer to as the SDI mode. But it's also about trying to build a learning economy, upgrading the skills of workers and farmers, and supporting the demand for knowledge. We also need to have this look at this as part of innovation policy. This has implication for the content of innovation policy, but also for how to coordinate. I have worked on this innovation policy in different countries for many years, and there are very many different ways to do it. In Netherlands, it's a Ministry of Finance who is in charge. Ministry of Finance. In Finland, at some point, it was the Ministry of Industry and Labor that was in charge. In Denmark, it was like a little like here, I don't know, the Ministry of Research in charge. Before that in Denmark, it was Ministry of Industry. Whatever solution, you get a very partial approach. So the interesting thing is that some of the countries most successful in innovation, they found a solution to this. They established a national council on science, technology, and innovation policy, and they had the prime minister. They had the prime minister as chairperson. Finland was the first to do that. Just a couple of months ago, a similar organization was set up in Sweden. So I think for Cuba, could be interesting to see if you could convince your president or to become the chairperson of National Council for Innovation, Development and Trade. Because then you would combine, you would bring in the Ministry of Science, you would bring in the Ministry of Industry, you would bring in the Ministry of Education and Labor, etc., all those, and you would focus to say the major challenge here is to develop a learning economy, a national system of innovation with Cuban characteristics. That's what you should do. So the role of universities in the learning economy. Universities should prepare students for lifelong learning. They should organize lifelong learning like tank stations for knowledge rather than knowledge factories. I would propose problem-based learning aiming at collective entrepreneurship competencies with elements of practice, stronger emphasis upon engineering and design. I think that are somewhat. And one important thing here, there's a lot of focus on how universities can be better connected to enterprises and rest of society. And this is very legitimate, but I would say it's as important to think about how you can stimulate the demand for knowledge in society. As I said to the minister this morning, if you want to build a bridge over a river, it's silly to build only from one side. You need to have an innovation policy where you try to stimulate the demand for knowledge. And this is often the more difficult thing than just producing more highly trained people and more research. One thing, when it's about building bridges between university and the rest of society, I think the students can play a major role. And I know that Cuba has a tradition for letting all higher education to have some elements of practice. I think that is very good. Because, as I said, there are some organizations which are very far from science, and just getting the students out there to do some of their own project research or something is a way to build the bridges. One interesting point is that when you think about higher education and innovation, you normally think we need to give people higher education so they will create innovation. That's okay. That's not wrong. But we need to think it the other way around. The best way to stimulate the demand for higher educated people, and there are some very important papers on that, is to stimulate innovation. When you have more innovation in your economy, the demand for higher educated people is increased. So this is why it's a good idea to think about higher education as part of a broader set of innovation policies, because it goes both ways. Yes? Yes. Plans for higher education need to be integrated into plans for building the national innovation system, and this is a reason for government to stimulate demand for graduates. Yeah. Of course, if you take this DUI, SDI point of view to enterprises, knowledge management needs to combine human resource management and learning with R&D management and information systems management. And you can say that you have three ways of bringing knowledge. I had this discussion yesterday about the importance of hiring people for this new biotech center, to finding the right people, but then you need to keep upgrading their skills by organizing research, by in-house training, etc. But you also need, today more than ever before, think in terms of bringing in knowledge from the outside by networking. And this can include knowledge from customers or users, from suppliers, knowledge institutions, and even from competitors. So these are, I say, knowledge management is to combine these three things: hiring, developing internal resources, and connecting to the rest, to the outside customers. Yeah. But of course, what is going on now in terms of the use of technologies, the building of new transport system, the new global communication system, global financial systems, etc., means that the local systems are under pressure. And it has implications, of course, for what you should do at the level of the university, the level of the enterprise, and the level of policy. I think one idea is that innovation policy should engage in what I call learning by comparing. Learning by comparing is not finding best practice, because what works very well in Finland will not necessarily work in Cuba. What works very well in China might not work. But still, comparing what you have and studying closely what you have and drawing some inspiration from the outside, I think would be a very good idea. I mentioned here comparing China and Russia, where Russia is perhaps a failure system in terms of innovation, while China is a more mixed success-failure situation. Finland is interesting, South Korea is interesting. Universities, of course, and you already do that, I know, and you are going to do that much more in the future, is to open up for interaction through students and researchers, global research networks. It becomes increasingly important. And the best way to get well connected in the most advanced research networks is, of course, to build excellence. If you have excellence in the field, everybody wants to join you. And so it's a dialectic between developing your own competence and getting connected to the best in the world. This will become increasingly important for universities. And of course, enterprises, and this is perhaps the greatest challenge for Cuba in the coming period, is how they can become more involved in global networks and markets, and at the same time develop further their knowledge base, develop further what they know good how to do, because if we look at the history for the last 50 years, we could see how globalization had a very negative impact on the knowledge base for some Latin American countries, Brazil, etc. When they opened up, actually some of their strong industries was wiped out. So this is globalization offers enormous opportunities, but it also offers threats. So I would say one of the greatest challenges for Cuba, both policy and enterprises, is to find a way to join these global networks in such a way that you do not undermine your competence, but you strengthen it. Learning by globalization. This will be, I think, the major challenge for the coming year. So this is my last slide, I think. I promise. If there should be some more. So the question is how to build a stronger national innovation system with Cuban characteristics, while at the same time entering more and more into processes of global exchange of knowledge, technologies, capital, and commodities. This is, I think, what is ahead of you. And you have to find out ways to do that in a very smart way. The key question is, what are the positive as well as the negative impact of increased international exchange upon the knowledge base and the learning capacity of your people? Thank you. No, we spring that. Okay, thank you very much.